All right, multiplying and dividing rational expressions. Number one, it's multiplication. So we can start by canceling things out. So there's coefficients and then there's variables. So coefficient wise, there's a 5 in the top. Five goes into 15 three times, and 5 goes into 5 once. Okay, when it comes to variables, there is an x squared in the bottom, and there's 3 x's up top. So we're basically going to take away 2 of them, so there's 1 left. There's a y squared in the bottom, and then up top there is 3, so we're taking away 2, so there's 1 left over. What else we have? So there's a single x up top and 2 x's in the bottom. All right, so if we can kind of see through the clutter, what's left? Y squared over 3x. All right, so I know it seems kind of convoluted, right? Right, kind of difficult and hard to see. You just got to be able to understand what you're canceling out and keeping track of what is still there, right? So I'm able to do that. If you can't, so much, the idea is that, so I'm going to rewrite the original problem. So 5x cubed, there's 3, y cubed over x squared, so 2x's, y squared, 15, and then x squared. So if you think of it like this, right, you just expand everything out before you cancel anything. And then here you see that, okay, multiples of 5, right? So 5 goes into 5 once, 5 goes into 15 3 times, and then you just start doing like a 1-for-1 kind of cancellation, right? So then when you tally it all back up top you have just 2y, so y squared, and then in the bottom 3x. So these are the two preferred methods. You either expand it all out or you just keep track of them as you cancel it out. So these definitely get pretty complex. Let's look at number 2. Here we have factors. Again, it's multiplication. So when it's multiplication, we're good to just start factoring and canceling. Looking at this, you can't really factor anything else. Everything is pretty much fully factored. So now we can play the cancellation game. So we look at what's on top and what's on bottom. So there's an x on top and a single x on bottom. Right, x minus 2 is not a single x. X minus 2 is x minus 2. However, the x minus 2 on bottom can cancel with the x minus 2 on top. And that's pretty much it. So what we have left over is going to be x minus 3, x plus 3. So underneath in the bottom, when you cancel things out, it's understood that there's a 1 left behind. And when there's a 1 left behind, we don't have to write anything. So just know that. Okay. Number 3. Again, it's multiplication. So we first factor what we can and then simplify. So you have to start looking ahead to see what GCF, right, greatest common factor, can come out. So top left, 3x minus 12, I can take out a 3. Left behind is an x minus 4. Check yourself real quick. 3x, okay, negative 12, we're good. All right, bottom left, x plus 5 is good. Top right, x plus 6 is good. Bottom right, I can take out a 2. X minus 4. Okay. Everything's fully factored. Now we can cancel. X minus 4, x minus 4. So what's left behind? Up top, we have a 3. X plus 6. And on the bottom, x plus 5. And then the 2. Sometimes when you cancel out a few things, it's always best to rewrite everything, and then sometimes it's a little bit clearer on what needs to be reduced. Here, it's already it's fully reduced in the end. Okay, 4. All right, so here we have to factor. So top left, looking for multiples of negative 4 that add up to positive 3. So 1 and 3, no, 1 and 4, right? 1 times 4 is 4. It's negative. One of them needs to be negative. So I need positive 3 when I add them up. So the negative 1, positive 4. So x minus 1, x plus 4. Okay, bottom left. Numbers that multiply to make 4 that add up to 4. That's going to be 2. Right? 2 times 2 is 4. 2 plus 2 is 4. So x plus 2. Top right, we can factor out a 2x. So left behind is going to be x plus 2. Bottom right, 2 numbers that multiply to make 3, positive 3 that add up to 4. So 1 and 3 needs to be negative. So both negative 1 and negative 3 multiply to make positive 3 and simultaneously add up to negative 4. So x minus 1, x minus 3. Okay, everything's fully factored. It's multiplication. Now we can start canceling. So x minus 1, x minus 1. X plus 2, x plus 2. That seems to be it. So cleaning it up top we have x plus 4, 2x, write that out front, over x plus 2, x minus 3. Okay. Leave everything in its factored form. Okay, number 5. It's multiplication. So top left, 2 numbers that multiply to make negative 36 that add up to 5. 9 and 4. 9 and 4 make it 36. We need positive 5, so negative 4. X plus 9, x minus 4. Okay, bottom left, that's a difference of squares. Difference of squares. X plus 7, x minus 7. Okay, right-hand side is not a fraction, but it's implied or understood that when it's not a fraction, any non-fraction can be rewritten over 1. Right? Anything that's not a fraction can be rewritten as over 1. So to factor this, So two numbers that multiply to make 28 that add up to 11. 7, 8, 9, 10, 11. So 4 and 7. It's positive, but it needs to be negative. So -4, -7. So x minus 4, x minus 7. Okay, everything's fully factored. There's no more separation that we can do. So let's start canceling things out. So what's in the bottom that's on top? X minus 7, x minus 7. All right, so that's about it. So rewriting everything, final answer, x plus 9, x minus 4, x plus 4 over x plus 7. Okay, leave it factored. Number 6. Top left. So it's multiplication, so we're good there. So top left, I can take out a 4, and I can take out an x. What's left behind? X plus 5. All right, 5 times 4 is 20. Bottom left, I can take out x squared. So x plus 4. Right hand side, again, it's over 1. Two numbers that multiply to make 16 that add up to 8. 4 and 4. And they're both positive, so that's good. X plus 4, x plus 4. Okay, everything's fully factored. X plus 4 in the bottom, x plus 4 in the top. All right, we have a single x up top, and there's two x's in the bottom, so I'm just take out one x. And that seems to be it. So writing the leftovers, 4, x plus 5, x plus 4 over x. Over x. Okay. All right, number 7. Here's our first case of division. So the idea is we keep the first fraction, we change to multiplication, and we flip the second fraction. So keep, change, flip. That's the idea. All right, so rewriting this thing. Do you have to rewrite it? No, not necessarily. A lot of mistakes happen when you rewrite it, but I'm going to rewrite it. So multiplication, and then we flip it. Y cubed, 30x, y to the 4th. Okay. It's multiplication now. Now we can start canceling. So you don't never want to cancel in a division problem with the division sign still there, right? Because if you try to cancel y cubed and y cubed, rookie mistake. Rookie mistake. Why? Because when you flip the second, right, the second fraction has to be flipped. That y cubed is not in the denominator anymore. It's technically in the numerator. So don't do that. You always want to flip it first. Once it's multiplication, now you can start canceling things. So there's 4 y's in the denominator, so I need to take out 4 y's from the numerator. So here's 3. I'm going to take out 1 from here, leaving behind 2. There's 1 x in the denominator, so I'm going to take out one of the x's in the numerator, right? Because there's 2. There is another x in the numerator, and I'm going to take out 1 from the denominator. So there was 7, now there's 6. Coefficient wise, there's a 5. 5 goes into 36 times. All right, so let's see if we can see through the clutter, right? That's the idea. Is there's slashes everywhere. Can we keep track of what's left behind? So up top we have y squared, right? Y squared. And in the denominator, x to the 6th, and then 6. So 6, x to the 6th. Okay, here's another one. Number 8. Division, right? So we're going to flip the second one. And it's multiplication. Okay, so it's fully factored. So that means we can start canceling things. So x plus 3 in the denominator, x plus 3 in the numerator. Single x in the numerator, single x in the denominator. Okay, that's it. Writing what's left over. X minus 2, x plus 1. Not bad. Okay, division. So it's tempting to just start factoring and canceling. You always want to flip the sign, change the sign, and flip the second one. So x squared minus 14x plus 45. So we don't need that anymore. All right, let's see here. Factoring top left, right? Because now it's multiplication. Now we can start factoring and canceling. So two numbers that make negative 27 that add up to 6, 3 and 9. Needs to be negative. So one of them needs to be negative 6. So that means the big one needs to be negative. So x minus 9, x plus 3. Bottom left, we can pull out a 2x, leaving behind an x plus 1. Top right, x squared. Can't do nothing there. Bottom right. Okay, two numbers that make 45 that add up to negative 14. That's 5 and 9. But negative 14. So both have to be negative, right? Because positive 45. So x minus 5, x minus 9. All right, everything's fully factored. What's in the bottom that's also in the top? X minus 9, x minus 9. There's a single x in the bottom. There's two x's up top, so I'm going to cancel one of those. Okay, I believe that's it. So what's left over? In the numerator, there's an x plus 3. There's a single x. All right, just so you can see it. So here's x plus 3 and then the single x. In the denominator, 2, x plus 1, x minus 5. So 2, coefficient goes out front. Wait, that's in the bottom. 2, x plus 1, x minus 5. Okay. Moving right along. Number 10. We have a compound fraction. Two fractions inside of a fraction. So when this is the case, we keep the top, the numerator, whatever it is. We change division to multiplication, and then we flip the bottom. So what I mean is x plus y, 2x plus y. All right, so we flip the bottom, and now that it's multiplication, right, we no longer need the bottom. We start canceling things. All right, so there's a rookie mistake here. the x plus y and this x plus y. That can't happen, right? Because of the 2. The 2 blocks that from happening. So x plus y in the bottom, there is another x plus y in the numerator. Now, the 2x minus y in the bottom and 2x plus y in the top, they look very similar. So the next rookie mistake is thinking, oh, that I can cancel out the 2x's. That you can't do that either. So when things are being added and subtracted, right, like in this case 2x plus y, when things are being added and subtracted, you can't just start canceling things out, right? The only time you can cancel things out is when multiplication is happening, right? So this is being multiplied in the numerator. These are being multiplied in the denominator. Now that things are being multiplied, now things can start canceling. But if it's strictly being added and subtracted, you cannot as easily cancel out things. So what's left behind? 2x plus y, 2x minus y. I believe that's the final answer. Right? There's no more common factors that can be factored out. All right, number 11. Again, it's division. So I'm going to change it to multiplication. And I'm going to flip the second one. X plus 2, 4x plus 16. So we no longer need this. Okay, factoring the top left. All right, here, the a value is not 1. What do I mean by the a value is not 1? I mean that this 3 is the a value. It's not 1. Because if it was 1, like basically if it wasn't there, we could probably factor this like the other ones. Or at least attempt to. But because it is there, we have to come up with other factoring techniques. So I like the slide and divide method. So if we rewrite this for a second, 3 times 4 is 12. So what two numbers multiply to make 12 that add up to 13? 12 and 1. So x plus 12, x plus 1. Our bottom left. Actually, we have to remember that because we did the slide and divide method, this really isn't the final factors. So x plus 12, x plus 1. Because we multiplied the 3, we have to divide by 3. Reduce when we can. So 12 divided by 3 is really going to reduce to 4. And 1/3 doesn't reduce. So we can kind of move up the 3 here. So what am I saying? I'm saying that the factors are going to be x plus 4, 3x plus 1. That'll give us 3x squared plus 13x plus 4. Okay, bottom left. It's a difference of squares. So x minus 2, x plus 2. Top right, x plus 2, it's already fully factored. Bottom right, I can factor out a 4. And then x plus 4 is left behind. All right, everything seems fully factored. Now let's start canceling things out. First thing I see, x plus 4, x plus 4. X plus 2, x plus 2. So what is left behind? 3x plus 1. Is that it? Yeah, that's it. So 3 x plus 1 up top. The denominator, x minus 2, and a 4. So the coefficients, those are the easiest things to miss. So 4, x minus 2. That would be the factored form. Okay, 12. So keep the top, change it to multiplication, flip the bottom. So these x's are y's. 4y squared plus 4y over 3y minus 3. All right, so we don't need this anymore. Okay, let's start factoring things out. So up top, we have top left. I can take out a 6. Left behind is a y squared minus 1. Okay, y squared minus 1, coincidentally, is a difference of squares. Right, you got to be able to spot these now. This is y plus 1, y minus 1. Right, because 1 is 1 squared. So y squared minus 1 squared is the difference of 2 squares. Bottom left, the 8y squared plus 8y. So I can factor out an 8. I'll write it down here. And 8y as a matter of fact. So what's left behind? Y plus 1. Okay, top right. I can take out a 4 and a y. And what's left behind? Y plus 1. And then denominator on the bottom right, I can take out a 3. Y minus 1. Okay, everything is fully factored. Let's see if we can start canceling things out. So first thing I see, y minus 1, top and bottom. Y plus 1, top and bottom. Single y. 3 goes into 3 once, 3 goes into 6 twice. 4 goes into 4 once, 4 goes into 8 twice. 2 up top, 2 in the bottom. Okay, what the heck is left over? So let's see, up top, y plus 1. Denominator, there's nothing left. So it's just a 1. So we don't even write it. So y plus 1. It's kind of crazy, right? Has something so complicated looking and it equals y plus 1. Okay, number 13. So it's division. So I need to change division to multiplication. And then we need to flip the second one. So I'm going to flip it and make it under 1. Because it's essentially over 1. And then you flip it and it makes it under 1. Okay, factoring the top left. 15, positive 15, multiplication, and adds up to negative 8. So 3 and 5. Since it's negative, they're both negative. So x minus 3, x minus 5. Bottom left, I can take out an x plus 4. Top right is 1. It's all good there. Bottom right, okay, negative 20. And it adds up to negative 1. 4 and 5. So negative 20, negative 1. So the 5 is negative. So x plus 4, x minus 5. All right, everything's fully factored. Let's start canceling. X minus 5, x minus 5. No, that's it. Right, this x plus 4 and x plus 4, they're both in the denominator. So what's left over? X minus 3, x plus 4, x plus 4. Could we write it as squared? Probably, but let's leave it factor. That's best. Ooh, all right. So let's see what's happening here. What is happening here? So negative exponents. It's going to make this 1 over x plus 1 over y, 1 over x minus 1 over y. When you're adding and subtracting things, right, terms, you can't cancel, right? It's so tempting, bro, to just be like, yeah, it cancels, right? But nah, it doesn't work that way. Strictly because of the plus and minus part. It's got to be multiplication. So I think what's best here is that we get a common denominator, right? I want to turn these two fractions into one fraction. So if I had just a fraction on top and just a fraction in the bottom, right? That's basically what we did over here, right? We can flip the bottom fraction, but I can't flip the bottom fraction right now. So check it out. Here's the deal. 1 over x plus 1 over y. This is prime example. You can always get the least common denominator or whatever the case may be. Sometimes a common denominator is just as good, right? And it may be the least common denominator, maybe it's not. But the fastest way to combine two fractions is whatever is in the denominator, that's the thing that I'm going to multiply the other fraction by, top and bottom, right? Y over y, anything over itself is 1. So I'm multiplying this by 1 and I'm not changing the value, right? 1 times anything is itself. I'm just using a clever 1. And the same is true for the other side, right? So again, the fastest way to a common denominator is to just multiply the other side by what's in the denominator of the other side. Essentially what's highlighted here. So what's going to happen is that the top is going to be y plus x, and the denominator is x times y. Right? Y times x and x times y, it's the same. Like, it doesn't matter the order when you're multiplying. All right, so this is the numerator. Y plus x, x minus y, x times y, xy. All right, let's try this again. This is going to be the same idea. 1 over x minus 1 over y. The minus doesn't mean anything. The minus doesn't mean anything. So the fastest way, and right now it's simple, right? The denominator is x and y. But if the denominator was something complex, right? X plus 1, like 1 over x plus 1 minus 1 over y plus 1. The fastest way is to just multiply each denominator by the other denominator. So y over y, x over x. So we're going to get y minus x over xy. So y minus x over xy. So now this It's not the answer, but this is a problem that we can work with. Right, so I'm going to keep the top, change it to multiplication, and flip the bottom. Right, this is going to come up. Y minus X. Okay. It seems fully factored. Well, I'm going to show you something here in a second. So if I start canceling things now, right, because it's being multiplied now, I can start canceling. XY in the bottom, XY in the top. So right now, cleaning it up, Y plus X, Y minus X. Okay, here's the deal. It looks like these can be canceled, or it looks like somehow like that's very tempting. That's not the case. Again, remember, when things are being added and subtracted, you cannot. So this is actually a good stopping point. Like you can't go any further. Like there's no way. All right, so you may have to watch this one a couple times, but the common denominator part, that's very useful, a useful tactic, particularly in this section. All right, we're almost to the bottom. 15. Nice. Little review on adding and subtracting polynomials. So here, because it's being added, right, there's addition. When it's addition, we can drop all parentheses and just start combining like terms. Right? Drop the parentheses and combine like terms. So watch. Let's see if this will work. Oh, I don't have white. It ain't gonna work. I thought it would work. Okay, whatever. Combining like terms. So 2x4, 10x4. 12 x to the fourth. No x cubes. Actually, there is. So 6x cubed. There's an x squared. Negative 2x squared. What's left? Minus x, that's the single x term. And then the constant. Right, the constant. Negative 7 plus 9, positive 2. Okay. 16. Right, here we have subtraction. So that means we have to distribute the negative to everything. So this would be minus 9 plus x minus 2x to the fourth. And that's going to be, basically it's going to flip the sign of everything that's in the parentheses. That's essentially what it did. And then everything in the first polynomial is just going to get added. So technically you don't even need to write it. We're just going to combine like terms at this point. So 10x to the 4 minus 2x to the 4, 8x to the 4. Plus 6x cubed. So start highlighting things because it's so easy to get turned around. So x to the 4, x cubed. All right, what's next? X squared minus 2x squared plus x. And then minus 7, minus 9. Negative 7, minus 9. Negative 16. Okay, here it is, number 17. This is a binomial squared. So the rookie mistake is saying that you cannot apply the square in this fashion. Like, that's not what this is about. It's saying that you take whatever it is, 2f plus 1, and you got to distribute. So everything in the first has to multiply to everything in the second. Okay. Now, there is, I wouldn't say a shortcut, but I definitely have a technique. If you've watched any of my prior videos, you for sure have seen this. This works specifically when you are squaring a binomial. So the first binomial times itself, so 2f times 2f gives me 4f squared. Positive 1 times positive 1 gives me positive 1. 2 times 2f times 1 gives me 2 times 2 is 4. F times 1 is just 4f. So there it is. So a times a, b times b, 2 times a times b. That's, so if this was a and this was b, a times a, b times b, 2 times a times b. They're all being added. Okay. You might have to watch that one a couple times too. All right. Z minus 5. Again, don't be a noob and try to cube everything. Right? It doesn't work that way. This is saying z minus 5 times z minus 5 times z minus 5. Okay. Now, there is a fancy way of multiplying everything, but that can get really complicated. So the idea is that we distribute 2 of them. Whatever answer we get, then we distribute the third one. So because it's cubed, I can do my trick once. So z times z, z squared. Negative 5 times negative 5 is positive 25. 2 times z times negative 5. So negative 10z. All right, so that's z minus 5 squared. Now I'm going to z minus 5. Multiply it times z minus 5. All right, this is going to be, so let's see. Z times z squared, z cubed. Z times negative 10z is negative 10z squared. And then plus 25z. Okay, the next one, negative 5 times z squared. Negative 5z squared. 5 times negative 10. Positive 50z. Negative 5 times 25. Negative 125. Is that true? 25 times 4 is 100. Yeah, 125. All right, let's start combining like terms. There's 1z cubed term. There are 2z squared, so negative 10 minus 5, negative 15 z squared, 50z, 25z plus 75z and then minus 125. That one's pretty intense. What are the instructions? Oh, just factor. All right. So now okay. So that was expanding it out or simplifying. Here we are factoring completely. Okay. I want to factor out a 2. Right, because they're both even. So 2w cubed plus 54. So 27. Right, 27 times 2 is 54. All right, this is where you got to be able to notice cubes. 27 is really 3 cubed. 3 times 3 is 9 times 3 is 27. Excuse me. So what this is saying, so here we have a sum of cubes. Sum of cubes is a very distinct pattern. So the pattern, if you remember from a prior video, plus, minus, plus. So this is going to be A, B, A squared, AB, B squared. Dang it. All right. So following this pattern, if A is W and B is 3, then this is going to be 2W plus 3W squared minus 3W plus 3 squared, which is 9. All right, and then we check to see if the quadratic can be factored. So two numbers that multiply to make 9 that add up to 3. 9 and 1, 3 and 3, and that's basically it. So we're good there. All right. What's next? All right, number 20, the last one. So it's four terms in descending order. So the idea is that we split it down the middle. So it's called factor by grouping. So you may want to check a video. It's one of the earlier ones. Factoring, right? Factor by grouping. So we're grouping the first two terms together, grouping the second two terms together. So the idea is that the GCF of the first two is 25 p squared. So what's left behind? P minus 1. Okay. The following two, the last two, if you can't take out anything, like obviously, like looking at it, it's like, okay, I can't take out any numbers, can't take out any variables. So when you can't take out anything, factor out a 1. In this case, because this is negative, right, I want to take out a negative 1. We're going to factor out a negative 1. And not only that, but kind of looking ahead, for this to work, this p minus 1, that needs to show up here. Right, that's the only way factor by grouping works, is if they match. So I have to factor out a negative 1. So then what's left behind? Positive 1, or positive p minus 1. Right, and that makes sense, because if you factor this back in, or if you distribute it back in, you're going to get negative p plus 1. So, okay. Writing the underlined parts. P minus 1. And then you write the leftover joints, right? Like leftover parts. Because the idea is that when we split it, right, I have two terms, the left side and the right side. And what's common to both sides? P minus 1 is common, right? Each side has a p minus 1. Therefore, I can factor out a p minus 1 from the left and the right. And that's exactly what's happening. So in other words, we say, well, when they match, you just write them down here, p minus 1. And then what's left over? 25p squared minus 1. Right, because if you were to distribute this back, right, p minus 1 times the first part, 25p squared, gives you exactly what's above. P minus 1 times negative 1, that gives you the second part. So there it is. It's factored. However, 25 is a perfect square, minus 1. So you got to be able to see a difference of squares right now, right? Like, you got to be able to see a difference of squares. So what this is saying is that 5p squared. All right, think about that. If I apply the square to the 5, I get 25. If I apply to the p, I get p squared. Minus 1 squared. This is a difference of squares. So this is going to be 5p minus 1, 5p plus 1. And then p minus 1 in the front. All right, this is fully factored. Is that it? I bet. So hopefully this helps someone brush up on factoring for sure. And I'll catch you guys in the next video.